So we're going to install this solar mini split made by EG4, and I have a bunch of products made by them, and they seem to be very well built. So this is a 24,000 BTU unit. It's a DC inverter unit, so it's very efficient. It only uses about 12 amps at the max at 240 volts. And it's not like a lot of other mini splits or other kind of compressor units where they require a huge load to start up. This really just ramps up, so you don't need a giant breaker on it. But the neatest thing about this unit is that it directly accepts solar panels. So it has a set of MC4 connectors here. You plug the solar array directly into here, and then it will use solar when it can, and when it can't, you can use the AC. So the AC converts it to DC when it's running on AC. So at nighttime, it will run on AC, or when you got clouds overhead or something. So this can accept up to 360 volts, and I believe it's up to 13 amps of PV on it. So the neat thing about that is, most likely if you're using this as an air conditioner like I am, most of the time I'm going to be using it as an air conditioner. It does do heating too, but the time that you're going to need the most air conditioning is when the sun's out. So that makes it really convenient, and you can plug solar panels into this without having to get permits and all kinds of things to backfeed to the grid and all that kind of stuff. You're just plugging directly into this unit, and there's no power going beyond this unit from the solar panels. So I don't believe that you even need a disconnect, but I will check on that. I'll let you guys know by the end of the video. And I wasn't going to do a video about just installing this because it's not a very big project, but I just kind of figured that this is really fascinating to me. There's not a lot of units that are a solar hybrid unit like this, and I really want to try this out, and then we're going to do some testing on it. And this is only 24,000 BTUs, so it's really not enough to run this garage. But I have a couple window air conditioners, and I also have another mini split that's not as efficient, but it will probably take up the rest of the slack that this doesn't do. So I think that this will do most of the cooling in here though. So I'm gonna mount this about midway in the garage. We got a 60-foot wall here altogether going out to that way. And so I'm gonna put it right about there. And the reason I'm choosing this side is because that's the north side of the building. So that side never sees any sun. So to have the compressor over there is the best because it's just a little bit more efficient rather than being out in the sun all day. So they want you to mount this about 8 feet up. But I think I'm going to do more like 10 or 12 feet up, because the higher up you go, the more efficient it is, because then it's grabbing the hotter air and pulling it in and cooling it. So the higher up you can go, the better, but I don't think I really need to go all the way up 16 feet. I think 12 feet's about good enough, because nobody's ever up that far, so the cooling doesn't really need to go up that far. So right now, because I don't have my wall covering, which is going to be metal siding, and I may not get to that for a long time, so I'm going to mount a 2x12 up there to mount this to. And then that way when we put our metal siding on, we can put our J-channel around that, and then off we go. And also we can stuff the insulation in behind that 2x12. So I had to wait to do this project until I got my siding on this side of the building, so that is done. What I want to do is drill my hole going through here. I'm going to use a 3-inch hole saw, and I've located the screws, and I've triangulated off of those screws so that I'm right in the middle of the ribs, because I don't want to really drill right on a rib or even next to it. I want to drill kind of like right in between them. So I'm going 2.5 inches to the left of the rib, which should bring me right where I want to be. So that's the hole that I want to drill, and then that way it looks nice and clean outside. So they give you this template, and here's the hole right here. So I'm going to line that up with the other hole. Maybe even just bring it up just a little bit, because there's going to be a condensate drain that's going to need to be pitched downward. So We'll go up a little bit with it. So that's about perfect there. And right there. Okay. And then the ground.
Your color for a ground?
No, it's actually pretty common. A yellow and gray. It's a pretty common color for gray, or for ground. I think this is this is a not used.
Oh, okay.
It's a connector for something that's, I remember them talking about that. Just needed some more of this insulation. You can cover that. I guess maybe we can stretch it.
Somewhat down.
Should be fine. But at this point, I want to do one of these. Yeah. Yeah. So I'm gonna push this down the line. Send it.
Okay. Okay. Okay.
Like another voltage. Have to kind of bring it over this way and then loop it around this way. It's gonna look like crap, but
The wrenches are over there. There you go. There's one. There's two. There's all three. All right.
Attached to them, look.
Alright, so we are ready to commission the unit. So at this point all we need to do is take these caps off, release the refrigerant. These lines are supposedly already vacuumed, so I have a vacuum pump that I could use for this, and I've done that in the past for other mini splits, but you could clearly hear it when I hooked these refrigerant lines in. As soon as it pressed the quick connect, you could hear something leaking down there. And that's not refrigerant, that's just the vacuum that was already in the line. Figure out how to turn it to
Fahrenheit and not Celsius.
yeah, you wanna
It's on the back of the controller. It usually should tell you.
press the temp up and temp down buttons for 3 seconds to operate the switch. Sorry, Europeans and every other part of the world except for us.
We use Fahrenheit.
64 degrees. I can already feel it.
Yeah. immediately. And then put that sucker on turbo. There you go. That gives you an extra BTUs. Sweet! You can't even read. If you turn the lights off, you might be able to see the display on. You can't see nothing.
What do you mean?
Kind
Oh,
of.
for the camera,
For
you
the
mean?
camera, I'm saying.
Oh, I don't know. So fast forward a few months, I've been using that mini split. I used it a lot for air conditioning, and I started using it for heating the other day actually. And I've been really happy with it. I'll show you guys some tests later, some usage history and all that stuff. But for right now, my parents want to install the same mini split in their house, and they're going to use it as their main heat source. And they don't really use air conditioning that much, or if at all, but they want to use it for heat. So it's 24,000 BTUs. This is a small ICF house, so it should be able to handle it pretty easily. They're also going to install some radiant heat in the floor, but that's going to be kind of a supplemental heat. Normally it's the opposite. The radiant heat would be the main heat, and then mini splits are usually supplemental, but in this case they don't have a geothermal unit for the radiant heat, so it's not going to be that efficient to use radiant heat. So being that this mini split is around a 3.0 COP, and I got to check on that, so don't take my word for it, but I'm pretty sure it's around a 3.0 COP. That's a lot more efficient than just using a regular electric heater. So to install this mini split, they're gonna install it in the main room, which is the living room slash kitchen slash dining room. My dad poured a little concrete slab right there the other day so that we can mount it there. So we're gonna mount it right here and pretty much go right up with it. Might have to go over a little bit, I'm not sure. There's a wall somewhere right here, but we're gonna have to punch through this wall, and this is an ICF wall. So they want you to use a 2.5 inch hole. So I don't really have a 2.5 inch, but I have 2 inch and I have 3 inch core drills. And I'm hoping I can do it without my big core drill, because the big one needs to be mounted to the wall. And since this is ICF, you got to remove a block of ICF to mount it. And I'm really hoping to not do that. So I'm going to try to use the smaller one, and hopefully I can use it with a 3 inch bit. And then that should be probably the hardest part of this install, is getting that drilled. Now that hole needs to be slightly pitched downhill this way. So we got to remember that while we're putting it in. So I got to figure out inside if there's any electric in the wall. We got to get it mocked up in there. And then I'm gonna come out here and drill it from the outside. It's raining right now, but we're underneath the gable overhang, so maybe we can still do it for a little while until it rains harder.
This wire comes from here straight up to the side.
It'll get cold in here because we have no.
Is that the end of the line for it?
No, it goes back down and continues on.
They have dirt. I walk with them outside and inside.
How are we gonna measure? Good.
Yeah, there is. What? Looks like it, I think. There's what?
Good.
That is cool.
Good.
We are here.
So now that I got that hole core drilled, while I still have the core drill here, I'm going to drill another hole right about there for the electric. And that's going to go into the basement, and we'll run that over to the service panel. And for that, I'm just going to use this 1-inch bit for this, which looks kind of ridiculous because the thread pattern for this is quite a bit bigger than 1 inch, but then it necks down to that. But it'll work for 1/2-inch conduit, and that's all we're doing. So I don't know how I got so unlucky, but I ended up hitting a steel plate for the back of the beam to rest in. There's a beam pocket in there, and on the back side there's a steel plate, and I hit it with the first 3 holes there, and then I finally got the last one. It went through like butter, but it doesn't like going through solid steel. I think rebar is one thing, but solid steel is another. So luckily we were going to mount this on a 8x8 square 1-inch PVC board, so that'll be covered up by that. But man, talk about unlucky.
closer. Yeah.
White pipe is pulling tape.
It's just that it isn't all the way around, I think. There's one bend back there. Is that thing just goes like that every time I do it.
Yeah.
So maybe if you went outside and pulled
Here,
this
I'll hold this.
Yeah, would be a good
You want me to go outside and hold?
Just the cord.
just the cord.
So you got just the cord, which means not the pipes, just the
Right,
Yeah,
just the wire. Keep going.
That's
Okay. Let him reach it.
hold it. Would it help when I go out there and tighten it by pulling it as best I can?
I think it's there.
Oh, okay.
That makes it look a lot cleaner. You know, one of the downsides to having a DIY type of system like this is the fact that the line set's obviously always going to be too long. If it wasn't, it'd be too short. So you always end up having to have a little loop there, but kind of is what it is. Most people are not going to put this like right at the front of their house where it's like a showpiece. It's usually on the back side where nobody can see. So it's looking the best it's going to be. My dad also had to extend that slab 3 times because we didn't know exactly where it was going to go, and he wanted to have the slab ready for me. So the unit isn't centered on the slab, and it is what it is though. This is the back side of the house. At least that looks a million times better. When the solar panels are hooked up, there's a green light that turns on, which you probably can't see, but it shows you right on the display panel right there that you're hooked up to solar. So right now we're getting 1200 watts of solar, and it's importing 700 watts of AC to make up for what it doesn't have. So I'm in heating mode right now, and heating mode uses more than AC. So right now we do have some sun, but it's kind of hazy. You can see that ring around the sun. So we're not getting full sun coverage right now. Also, these panels are quite a bit dirty, so that's contributing as well. But this is 6 405 watt panels. They're bifacial. I don't think we're going to get any bifacial gain out of them right now, because the back side of them needs a few feet to be able to reflect the sun. So right now there's not much reflection going on. But if the sun wasn't behind a little bit of haziness there, then in theory we should be getting about 2400 watts. So when this mini split is in cooling mode, it uses around 2000 watts. When it's in heating mode, it's around 3000 watts. So we need a little bit more power during the winter time, and also the sun is lower, it's further away, and you get less sun. So I would say you want to probably be running around 8 panels at least during the winter time. 8 times 400, that's about 3200 watts. That would cover most of it, but it's not going to cover it when it's hazy out or cloudy. So this system could be really neat for somebody that doesn't already have a big solar system, or has a solar system that has a small inverter that's maxed out with panels. If you have the capability of having an inverter that can take all the solar that you want, it doesn't make too much sense to have this kind of system, because you can just add the solar panels to the system, and then that way when you're not using the heating or cooling, you can get the benefits from the panels. Whereas in the shoulder seasons, if you're not using the system, then the panels aren't really doing you much good. But if you're maxed out on your solar and you can't put any more panels on it, or if you just don't have a solar system, you don't have an inverter, you don't have batteries, this system is really nice, because you can add these panels to the mini split. You don't have to get any extra permits, as far as I know. I'm not 100% sure on that. It may depend on your area, but since you're not plugging the panels into your electrical system, you shouldn't need any kind of permits for it. because these panels are plugging directly into the mini split. And yeah, you'll probably need a permit for the mini split, but plugging the panels directly into it, you probably want to just have a shutoff switch on it. But other than that, you really don't need a whole bunch of different stuff for it. Now, if you mount your panels on the roof, you may need a building permit for that. If you mount your panels on the ground in a ground mount system, you may need a permit for that too. But if you mount them, say, on your wall or on your shipping container, or just lean them against the wall, or there's various things that you could get away with without a permit. Probably. I don't want to say that for sure because different areas are different. But most places probably wouldn't care if you had a few solar panels leaning against the wall that were hooked up to your mini split. And most places wouldn't care if you also hooked up your mini split without a building permit, as long as you hire an electrician to do the electrical part, or you pull a permit or both for the electrical part. They'd probably be fine with that. But for somebody that's got an off-grid place, this is a really nice system, because you could just hook it up in a way where you don't even hook up the AC side of it, and then that way it only turns on when it's got enough PV power. That would be ideal for somebody who has a small off-grid place that's got a small off-grid power system but doesn't want to tax that system by putting this mini split on there. Now, you can also get a smaller mini split too. This is 24,000 BTUs. You could get a 12,000 BTU system, and they also make a 9,000. I think the 9,000 is not solar though. I think just the 12 and the 24 are solar. So with a 12,000 BTU system, that's a 120 system, and you could get away with like 3 or 4 panels with that. And that's ideal for like a tiny house, tiny cabin, mobile home, something like that. Now, obviously for this garage, I need as big a system as I can get, and 24,000 BTUs isn't quite enough, but it does do the trick for the most part. As far as cooling, it's everything we needed in there for cooling. I was very surprised by that, because if you do the calculations, I should need 3 times this system for cooling. But this did the trick, and that's without insulation. I don't have any insulation in here. So if I insulate everything, this will do a lot better. And as far as heating, yeah, it definitely falls short on the heating part, but it will keep the building above freezing, which is about the most I can expect right now, because 24,000 BTUs to heat 40 by 60 shop, that's 2,400 square feet, and that's really 2 stories because that's 16-foot walls. That's like 4,800 square feet that you're heating. So yeah, 24,000 BTUs is not going to do that. But if I was fully insulated, it would definitely get me a lot closer. And my whole goal here is to have the radiant heat in here and then use this as a supplemental heat, or to kick the heat on real quick. Because let's say I'm away for a week up north or something, and I want to come back and turn the heat up. Well, that radiant heat's going to take a while to kick in. So you kick this system on at the same time, and this will kick the heat up a lot quicker than the radiant heat. And then once everything's up to temperature, you shut this system off, or you use it as supplemental heat or whatever. Now, it's obviously not going to perform like a geothermal system, because the colder it gets, the lower that COP gets. So at some point you're down to 1-to-1 ratio with electric heat. I don't know where that point is, probably somewhere around single digits. So when you get to that point, yeah, it's not super efficient versus a geothermal system. But it's not like you're dealing with that for half of the year. You're only dealing with that sometimes. That's why geothermal systems are so nice, because it doesn't really matter what the temperature gets down to. Your ground temperature stays the same. Now, if you pull a lot of heat out of the ground when it's really cold, then your ground temperature does lower, so your efficiency goes down as well, but not near as much as a system like this, which is taking the outside air temperature and converting it to inside air temperature. So if the ground stays at 50 degrees, but then you're pulling so much heat out of the ground that it actually gets down to 40 degrees, yeah, you're losing some efficiency, but you're not losing efficiency versus the 0 degrees that it might be outside. So you're still 40 versus 0, and you're transferring the heat with water or a liquid versus air, which liquid is much more efficient to transfer heat. So yeah, a geothermal system would be a lot better, but it's 10 times the work to put in a geothermal system, or more, and 10 times the money too. I just went through that with my house. It was a lot of money and a lot of work to put in that geothermal system. Now, I'm really happy in my house because I'm also heating hot water with it, and I'm doing radiant heat. I'm doing cooling with it and everything else. I was gonna do that on this garage. I do have a geothermal system for it. It's an older one though, so it's not gonna be as efficient. But I decided recently that I don't really wanna deal with that, not right now anyways. I'm kind of thinking what I want to do for this building is just do a wood boiler, because if I can find one used for like $1,000 or less and install it, it's so much easier and cheaper. And I can also use wood like from the sawmill. Like you can use pine and stuff like that, so you're using scrap wood instead of going out and buying firewood, which I would never buy firewood, but I'm just saying you're not even using good firewood that I could be using in a wood stove. You can use any kind of wood that you want. Like scraps from the sawmill is perfect because we have a lot of that. So an indoor wood boiler is probably where I'm going to end up pretty soon. I was going to do a air to water heat system, which is similar to geothermal, but you're not using the ground source, you're using the air source again. You're pretty much installing a system like that, but it converts it to water to go inside for your radiant heat. But even that's going to be like 10 grand, and actually it's probably even a little bit more than that, but I think a wood boiler would just be a lot cheaper and easier right now. So in the future I may install either an air to water system or a geothermal system, possibly. It really depends. I don't want to spend forever on it, that's the thing. Now, it's not nearly as complicated to do a geothermal system on this building versus my house because I'm not doing cooling with it, but at the same time, it still is involved. I still need to put a ground loop in or a well, and that's a lot of money or time. And that's just not something I really want to deal with right now. But maybe next year, maybe the year after that, I don't know, we'll see. But the thing I really liked about this system is that it's so cheap to buy it, and it's quick to install it, and you can do it yourself. You don't need to hire an HVAC guy that comes out and does the refrigerant part of it. You know, it's just something that's quick and easy. And for air conditioning especially, I'm not going with geothermal air conditioning no matter what. So this is definitely the way to go, because the only other option really is just window air conditioners, and I definitely don't want to do that. So eventually I'm going to cover up these pipes and do it like I did on my dad's system where it looks nice, but I need to order that kit. So for right now I'm fine with this. And this is on the back side of the building, so you really don't see this from anywheres. Now, one of the only downfalls I see to this system is that it only goes down to 61 degrees. While that may not seem like a big deal to people that are using it for their house, for this garage, I'd like the ability to go down to at least 50. That way, if I'm away for a week or two, I don't need to keep it at 61 in here. I just need to keep it above freezing, which even 40 degrees would do that. So 61 is pretty high for a garage that you're not using for a few weeks. So I think that's one of the only downfalls, but that's not really that much of a downfall. I wouldn't not get the unit for that, for sure. Like, it's a great unit other than that. But the fact that this unit does accept up to 360 volts is great, because that will allow you to put a lot of different combinations of panels in. You can either do a bunch of them in series, or you can do parallel, because if you do them in parallel, then it will limit the amps if it needs to. You just need to use bigger wire. If you do it in series, at least you're not going to over voltage it, which will damage the solar controller in it, the charge controller. If you compare it to this system, which has a max voltage input of 60 volts, that's 6 times that, which it should be the other way around. This one should have 360 volts of input, and the other one should have less, because it doesn't need quite as much power. This should have a great solar system on it, but it doesn't really. And I've covered that in other videos, but this is still a great system, but that's just one limiting factor to it. So I will have a link in the description for this unit as well as the smaller units, and I got these from Signature Solar. They are a great company to work with. I've worked with them a lot with all the solar stuff. So I will leave a link in the description for all that stuff. And if you guys decide to buy it and you need to ask me questions about it, feel free in the comments, or you can even email me. But I guess that's it for this video, guys, and I will catch you on the next one.